Nice.
Good? All
Yep, we're
good?
live.
We're live. Okay.
Yep. Welcome,
So,
everybody. We're here today with a very special guest, a longtime friend of all of my platforms and shows, and a longtime crusader for the truth of the cosmic origins of life and space, and so many conversations that we can have with this man. I mean, he's influenced my life and many people's lives out there. We have a very special guest, everybody. Professor Chandra Wickramasinghe. He's an astrobiologist. He's a mathematician, an astronomer, award-winning professor, and just an all-around Renaissance man and great guy. Everybody, it's a pleasure to be able to spend some time with us here on the Space Water Podcast. Welcome back, Professor Chandra. I'm really happy to see you, and I'm glad to finally catch up with you again.
thank you very much, and I'm very glad to be talking to this great descendant of a guy called Giordano Bruno, and he has been my hero for a long time. He was, of course, I think, killed in 1600 or something, right? Close to 1600.
Yes, I think in 1600.
My wife and I actually visited the statue of Bruno not so long ago, a few years ago, and I mean, I was quite impressed by his appearance. Even in stone, he was quite a austere character. Anyway, I reckon it was 1600. He was killed by the papacy for declaring the truth about life in the universe. Uh, Planets everywhere, inhabited planets everywhere, and so on. So this was a great opportunity we had to actually stand under the shadow of this very great man. Now, some 500 years later, after Giordano Bruno was murdered by the papacy, myself and my late colleague, Fred Hoyle, and a group of students and collaborators suffered a similar but less fatal uh, experience. It was a less brutal fate. The fate that we suffered, of course, was we argued that life was everywhere. We produced the new evidence from astronomy that life had to be a cosmic phenomenon. And for this, we were essentially ostracized by a huge scientific organization right across the planet. And so it sort of harks back to the days of 1600 and Bruno in a sense. But in the 1970s, I think people or humans are a little more civilized. They didn't murder the people they disagreed with. They just left them alone. Or essentially, we call them stupid or maniacs or whatever. But I think I should say that the truth always prevails, and it would do so in the case of life in the universe. The thesis that Giordano Bruno, amongst many others, Copernicus and so on, started all those years ago. These pioneers were ignored and forgotten, and since 1970, we had a new group of similar adventurers in space, that is myself and my colleague Fred Hoyle and a lot of others who took a very similar path to trying to understand where we are in the cosmos. How do we stand in relation to all the other planets and all the other stars in the universe? My own personal project started in a fairly innocent way. I began to study, I should say restudy or reinvestigate the nature of cosmic dust. Now, these cosmic dust clouds are seen right across the Milky Way. If you happen to be standing in a very clear night, you see the Milky Way sort of arching across the sky from horizon to horizon, sort of sea of stars. But in between the stars, there are also dark clouds in various shapes, elephants' trunks, and so on. And it is the nature of that dust in those clouds that we began to investigate in the mid-1960s. And the results that we were getting from the late 1960s onwards to me, were really stunning. We found that the dust was not made of tiny ice crystals, as water ice crystals, as astronomers had maintained for a long time. They were made largely of the element carbon. Now, carbon is interesting and important because it is a main component, or it's an important component of life. At the beginning, however, our carbon models of this dust in space were relatively simple. We started with soot-like particles. Then we ended up with organic molecules, organic particles, organic dust. And in 1974, I think, I published a paper in Nature saying that the dust in space is made of complex organic polymers. And I pointed to a particular polymer, which is a component of all sugars, a polysaccharide. And in this case, it was cellulose. But this was just sort of the first steps towards maintaining, or starting to maintain, that life is not really connected with the Earth primarily. It is a truly cosmic phenomenon. And for making these statements, of course, there were many plaudits, and people said this is a great idea. But the important, influential people in science started to criticize us in a very brutal way, partly because they felt they didn't think about this thing themselves. And one of the people who really criticized us right from the beginning was a man called Carl Sagan, an American scientist who's a very popular scientist, a public figure, in fact, in science, in astronomy at the time. So he wrote a letter to Fred and me saying that, well, the dust looks like a mixture of organics, looks similar to living cells. But if I were to take a suitable mixture of organics in the lab, I might get the same picture, same result. Now, of course, that was total bogus bullshit, I would say, in polite jargon, right? The results that we had in the 1970s, late 1970s, early 1980s were really quite powerfully pointing in the direction of biology everywhere in the cosmos. The spectrum of a bacterium, of a dried out bacterium, appeared to be reproduced everywhere in the cosmos. Now, of course, like Carl Sagan, you could say that this is just a coincidence. You have the bits and pieces that made up the bacterium, organic molecules thrown out in space in the right proportions, and then it would mimic the properties that we regard as bacterial. But that's essentially, I think, beating all the rules of science. We're using, if you use what's called the Occam's razor, this was the first statement that should have been ruled out completely. So bacterial particles in space, that began to gain ground amongst myself, my colleagues, Fred Hall. We propagated that in a big way in the literature. We looked for more and more evidence in astronomy, and we were finding such evidence. So the cosmic dust was, we reckoned, truly living, in the sense that they were the seeds of life in the cosmos. So this really, at this point, we were basically reviving an ancient doctrine, a very ancient doctrine called panspermia, which preceded the reigning doctrine of science at the time, which was the doctrine of spontaneous generation of life. The doctrine of spontaneous generation of life says that whenever the right mixture of simple organics, water, and the right conditions prevail in a small puddle or something, or in the oceans, then just life would immediately emerge. And that, again, when we analyzed the mathematics of it, turned out to be total BS, as they say, in polite language in the US. There's no way in which the exceedingly complex, intricate complexity of life could be reproduced by random processes in a small little puddle, in all the oceans for that matter, on the Earth, or all the oceans in all the planets in the universe. So life as a truly cosmic phenomenon distributed everywhere, seeds of life distributed everywhere, was the counter theory, counter to the reigning dogma, which was spontaneous generation, and it was called panspermia. Panspermia predated the spontaneous generation story by a couple of centuries. It is attributed in the West, in the Western world, to a philosopher called Anaxagoras, who lived in Greece, in Athens. But even much earlier, the same idea of life everywhere, essentially panspermia, was an integral part of ancient Indian culture, ancient Indian science.
Sanskrit and the Vedas, yeah.
Yeah, the Vedas were full of the great truths of science, including the eternity of life, and the eternity of the universe was also one part of this story, which was simultaneously, I should say, being challenged in the 1980s. The
Yeah.
cosmology was being challenged, and the Big Bang cosmologies were
Well,
being challenged.
speaking of Giordano Bruno earlier, I mean, nowadays I know there's no room for meditation and things like that in astronomy and biology and astrobiology, but how much you think of the spiritual side of tapping into the cosmos is now missing out of science and astronomy? Because that was a big part of Giordano Bruno's way of tapping into the truth, the universal truths of the cosmos.
That's right. I think that is totally missing because our culture essentially forbids that kind of activity. But my personal belief always, I was sort of brought up in Asian Buddhist traditions, and my belief, partly based on my Buddhist background, has been that uh, if we probe very deep into our minds, into our deepest conscious states in our mind, then the truth about the universe must naturally emerge. Because if we are creatures of the cosmos, if we are really truly creatures of the cosmos, the truth about the cosmos, the truth about life, the truth about the universe must be inherent in within ourselves, within our deep minds and consciousness. So I think this is not a scientific statement, but I sort of believe that this is probably uh, a valid argument to sort of moot in a philosophical sense, if not in a scientific sense. But science is moving in the same direction. There's no question now, for instance, with the latest discoveries of the James Webb Telescope, that the universe is probably much, much older than has been hitherto believed. The Big Bang universe that people had sort of almost, they were entrenched in that belief for a very long time. That's proving to be totally bogus, totally wrong. An age of the universe of 13.8 billion years,
Yeah.
just forget it now, because there are stars and galaxies that are perhaps even older than 13.8 billion years, arguably. So galaxy formation has taken place at times that the universe should not have been doing this, according to the Big Bang.
The
So
James Webb is proving us what we thought every day wrong.
absolutely.
Yeah.
And that's for the
Incredible.
universe. And then think of what it is proving in the case of life, right? We talked about panspermia and life in the universe being a truly cosmic affair. Recently, only about 4 months ago, I think, the James Webb Telescope scientists reported the discovery of a biological molecule in what is called an exoplanet, some 124 light years away, right? But the amazing situation that we face now is this has been admitted. The scientists say that yes, there is this molecule. It's called dimethyl sulfide, and the only way that we know that this can be produced is by living processes. So there are hot, warm water oceans on this exoplanet, and microbial life sort of essentially pervades. But next thing that they say is that this certainly proves that spontaneous generation is taking place very easily. Total rubbish.
This is
That
the picture in front of us right now, right?
That's a picture in front of us.
Yeah.
On this planet, they discovered a molecule. It's a planet called K218b, and as I said, it's 124 light years away with hot water oceans. And there is a molecule called dimethyl sulfide, which is only known to be produced by a certain type of bacterium. So life, yes, that is vaguely admitted, is at last, long last being admitted, life outside the Earth. But the statement is that just like life started on the Earth by this magical, mystical process of spontaneous generation, it is starting everywhere, right? Probability totally rules it out. Simplicity of argument rules it out, and the sheer facts of the whole story make it very, 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 very unlikely that this is the outcome of what's been discovered. I think rather we are finding the expected result of panspermia, of life everywhere, where the components of life, bacteria and viruses, are essentially all pervasive throughout the universe, throughout all time. And whenever there is a planet, whenever there is an environment where these things can take root, they take root. Right? It's not that spontaneous generation is taking place everywhere. It's that the components of life in the form of bacteria and viruses are everywhere. And they're just getting together into structures, into living entities on any place where the conditions are favorable, where the physical conditions are favorable. So, I mean, this is the obvious result to accept, but I think the situation is that science is very reluctant to do that, because if they say that, then they've got to say that Hoyle and Wickramasinghe and all their nasty colleagues were right all along. They don't want to say that. They want to say, continue to say that we are wrong, we were wrong, and this is a different, that what they're finding is much more important, and a different story. Again, this is totally bogus. Another setting in which this same molecule has been found is in a comet uh, called 67P-CG that was investigated by spacecraft that landed on a comet. This is the Rosetta mission. And we examined sort of late in 2015-16, we examined all the data from this mission, and we concluded that there were signatures of bacteria on the spacecraft and the sampling that was done. Nobody took it seriously. They thought these are just organic molecules, random associations of organic molecules. Now they have taken a spectrum of this same, investigated this object, the comet, a little more in detail, and they find the same molecule that is in the exoplanet, which is dimethyl sulfide, present on that comet also. So now,
Didn't they, Professor, didn't they have during the Deep Impact mission, wasn't there Temple? Didn't they find
yeah,
that there, yeah, wasn't that organic as well?
yeah, that was organic, and that produced a huge flood of stuff that we analyzed the spectra of, and we concluded that it was fully consistent with living organisms. So nobody took it serious. We had this stuff published, of course. There were journals that were willing to publish this material, but the orthodox science community didn't take any notice of it for quite a while. They haven't taken any notice of it because it came from Hoyle and his colleagues. Now they're finding the same stuff on the same comet, not the Deep Impact comet, but the Rosetta mission comet. they're finding the molecule that they say signifies life. And they're in a dilemma because they had declared the comet to be a dead planet, dead comet, on the basis of the data that existed in 2013,
It's
14.
incredible because I see people like Neil deGrasse Tyson talking to astrophysicists saying, "Oh, I can't believe you guys are gonna find organics on asteroids. Like it's something new. You guys have been talking about it over 40 years."
Yeah. Yeah, we've been talking about it 40 years. And this is an interesting story that I knew a guy called Arthur C. Clarke very well. He was also a long-term resident in Sri Lanka. I've met him many times. And in his last book that he published, which says, I think the title is Carbon-Based Bipeds or something, uh,
Wow. Well, he was incredible.
he was incredible. And he gives year by year account from 2000 onwards of what the world would see. In fact, in 2023, his prediction is that AI would take over, become more important and more intelligent than human intelligence, right? And this is almost coming to be true. And at the next return of Halley's Comet, he predicts that Hoyle and Wickramasinghe would be 100% vindicated because they would find living organisms crawling all over the comet. That that
Wow.
is, that is Arthur Clarke's prediction.
I
But I
remember
mean,
you telling me when Arthur C. Clarke was at your house, he came and saw evolution from space, or was it
diseases
disease?
from space,
This
I think.
oh,
And
this
both.
one. It was this one.
Yeah,
Diseases
that's
from
right.
space.
Yeah, yeah, yeah. And he said that he just had a visit from the head of FBI or one of the American top security organizations. And this guy looked at the book, picked out the book, and said, Arthur, these guys have got it right, but we're not supposed to tell you this.
Wow.
Right? So they have found microorganisms in the atmosphere, and it was it's not been revealed whether this is true or not. I mean, Arthur has been known to spin yarn. He's a
Well, he's a
scientist.
storyteller. He likes a good story.
I can't vouch for that story, but that's sort of interesting. But this is the way that science is progressing. Whenever new discoveries are made that essentially backs up our theories, they are generally either ignored or degraded or attributed to other people. And very weak results that are obtained by spending huge sums of money are given more uh, credibility and more acceptance than the very strong results we obtained with almost zero funding. Right, so it's almost ironical that our funding was minimal, and we just looked at the data, studied the data in the lab, used our calculators in our heads, and we got a certain answer to big questions. And the same answers are being obtained in snippets now, using big telescopes, and they are given huge publicity and ostensibly huge credibility because a lot of money has been expended. Now, I think we can't leave that story without referring to what's happened recently. There's been an American mission to the moons of Jupiter, right? Launched, I think, a couple of months ago. This is due to reach Jupiter in about 3 years' time. Reach the
Wow. Like even Io, the volcanic moon?
not the volcanic moon. I think it's Europa is the main
Oh,
target.
okay, yeah.
And Europa is a moon that has
Wow.
fascinating moon with a cracked icy surface, maybe with deep oceans, liquid oceans, and so on. And it is a satellite which, again, coming back to Arthur C. Clarke, he has said that there will be intelligent dolphins swimming in the seas that
Wow.
beneath the icy crust of Europa. Well, I mean, I don't believe that's to be the case. That would be the case, but they would certainly find life there. There's no question about it. They would find evidence of microbial life. And this again would be a story. Oh, of course, spontaneous generation has taken place there. Mystical process of spontaneous generation.
Yeah. I always found the magnetosphere of Jupiter very interesting because it doesn't form from the solar wind like ours does. It forms from like the spin of Jupiter,
Absolutely. Yeah.
right?
Yeah. 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 Yeah, it's a planet with a huge number of mysteries.
And it
Some,
gets its plasma in the magnetosphere not from the solar wind, but from the volcanic moon.
yeah, because it's throwing up material, and the material is getting ionized, right? And
Wow. Yeah,
plasma.
it's the plasma torus, right? There was a, how there was a book that I got. I don't know if you ever got this. This was from when they did the first missions, the physics of the Jovian magnetosphere.
No, I don't know. I know Dressler, but I don't know the book, this particular book.
Yeah, Dessler. Yeah, yeah. I wonder. This was from when did they go? It was Voyager,
Yeah, I mean, from about the 19
1979 or something. They went a mission. I think it was.
mid-70s, there have been so many spacecraft going to all of these moons, finding tantalizing evidence that could have been interpreted as biology even then, right? And even sort of going as further out to the planet, the satellites of Neptune and so on, and Pluto. These have been totally degraded. The data has been degraded because they don't want to admit that there could be life there. But now I think the situation is slowly changing. And as I said, with spending a lot of money, they're getting very weak data and they're making strong claims based on weak data, whereas the claims are
So
already very
true. So true. So did you work on the steady state theory at all with
yeah, I did
Sir
marginally.
Fred
I
Hall?
Fred Hall had two students working at the time that I was in Cambridge. One was myself, of course. The other was a man called Giant Nalika, with whom I have also collaborated. We've written papers on even on exobiology or astrobiology. He was involved, for instance, in the recovery of particles from the stratosphere, where we found evidence of microbial life. But he was a cosmologist, and this is a picture that you have here, which is being absolutely vindicated by the James Webb Telescope data. Right, James Webb Telescope data is showing us that the universe is certainly older than was hitherto believed, that galaxies are present when the universe was marginally existing, was newborn, if you like to put it that way, or even before the universe was born, if you believe in Big Bang cosmology. So there are lots of contradictions that are emerging. These are being essentially sort of glossed over or plastered over by the establishment who still doesn't think that the Big Bang Theory should be rejected. But Nobel Prize winning scientist Roger Penrose and my colleague Nalika with Fred Hoyle propose a universe model that has an eternal existence, right? And it could be such a model that we are living in, and we are living in a phase where the universe is expanding, and at a later time it will contract and then expand again, and that's the picture that you see here. So things are changing right across astronomy, from the microscopic life forms that we're seeing in these exoplanets to the very structure of the universe being challenged. Orthodox views are being challenged. So I think we're living in very exciting times, and a vast body of evidence is really seriously threatening and challenging accepted scientific views on the universe.
This is from Sir Fred Hoyle's one of his books, Professor,
Mhm.
when he was talking about steady state.
Yeah, I mean that seemed to be the natural model to explore. People didn't want to explore it at all because it was running contrary to the really well entrenched Big Bang theory of the universe.
Can you
Uh,
explain for people listening in the chat room and everything out there, and I have a question or two, I think. Can you explain people the idea of steady state?
yeah, I mean, the Big Bang Theory started with the first detections of galaxies sort of receding at greater and greater speeds, moving at greater and greater speeds. The further away the galaxies, it seemed as though to us the galaxy was moving at greater speeds, right? And the picture that people made of this is to say that everything emerged from one gigantic sort of super universe, a point a point universe with all the mass, everything in there, and then it exploded, and then everything started from there. That atoms formed, stars formed, galaxies formed, and so forth. So that's the standard Big Bang theory, and that's been around for pretty close to 100 years. Now, in the 1960s, 50s, late 1950s, Fred Hoyle, Herman Bondi, and Tommy Gould suggested that the universe might be totally different from the conventional Big Bang theory. It may be in a steady state where the universe appears to be moving apart. Bits of it are moving apart from one from another, but there is always new matter created, or it could be sort of an oscillating universe. There could be phases in which the universe is just going away from each other, parts are going away from each other. And then this is the kind of picture that you have there, uh, an undulating universe. That's been the Hoyle-Nalika position, and started with Hoyle, Bondi, Herman Bondi, and Thomas Gould, the American scientist. But it didn't take off. It was even more violently opposed than the panspermia ideas. When I was around in Cambridge, astronomers were finding evidence that they claimed proved beyond doubt that the Big Bang theory was right. Radio astronomers in Cambridge were at arms against Fred Hoyle for uh, promoting the steady state or a challenge to the Big Bang cosmology. So it was a difficult time in Cambridge, and then there was also in 1965, I think it was, the discovery of what is called the cosmic microwave background. Right, two American astronomers.
CMB.
Yeah, that's right. Discovered that the whole universe was bathed in a sea of microwaves, and this was therefore an indication that there was a hot universe, and the universe has been cooling ever since.
So that's just like a super ionized plasma then,
That's
basically?
right. Yeah, yeah. Well, there are many other explanations for it, and but the explanation that stuck and got really entrenched in the orthodoxy of science is that the Big Bang theory was now irrefutable because the microwave background proved it. There have been many other sort of little flaws that have been pointed out, little problems for the Big Bang theory, but each and every one of these have been systematically plastered over by
Yeah.
the promoters of them.
So
And
and Fred Hoyle's, it was so he believed maybe like there could have been little big bangs everywhere, sort of like quasars maybe.
yeah, he believed, no, the quasars are little big bangs in a sense, but he
Yeah,
believed the whole universe had an eternal existence. It contracted, expanded, like in the one of the pictures that you're showing here.
yeah, that's interesting.
So that these are the models that were the rivals to the Big Bang cosmology. And in the last year, again, this is the James Webb Telescope, turning up with data that shows that the Big Bang theory is in really serious trouble.
Huh.
So, people still think that they can recover from that. I don't know whether that's true or not, but
All the money that was spent, all that they don't want to. It's a shame that it's dogmatic like that.
yeah, I think money is a really corrupting influence in science. The more money you spend, the more you are locked into a certain set of ideas that emerged from that spending of money.
Did you and Sir Fred Hoyle and maybe even Arthur C. Clarke ever uh sort of bounce around the idea that maybe our solar system could have been born from a binary system originally, like it had a binary companion, and maybe the companion it lost its companion star
Yeah,
along the
maybe
way.
that's a point of view that's been around for. We haven't worked on it in any detail, but the missing companion to such a system has been a problem that astronomers have been addressing. Whether that is true or not is unclear at the moment. I think it's not a matter of importance in relation to either the origins of the universe or the distribution of life, but it's an interesting question.
Yeah.
Does the sun have a companion star?
Yeah, I think they have
Hmm.
the Tychos theory
Yeah,
that had to do with Mars even, I think, as
yeah.
well. Yeah, I always wondered because even the asteroid belt is outside of Mars and Jupiter, between Mars and Jupiter, where
I
that
think
came from.
Yeah. I think all of this stuff is it's up for grabs now. So some of the material that you see in the solar system, the asteroid belt, the comets, and so on, possibly indigenous to the solar system, but there could be a lot that is not indigenous to the solar system. I think we are a mixed bag of stuff. We have stuff from our local origin of the solar system and from subsequent incursions into the solar system of material from much further away. So the whole galaxy is on this picture rather mixed. It's totally mixed, and that's very important and interesting for our ideas of panspermia also because it means that life and the genes of life are mixed right across the universe, right? So our genetic composition as humans, butterflies, animals, and so on. That composition is not necessarily unique to the Earth. We may have many other places, faraway places in our galaxy, even where the uh, same genes have got together in pretty much similar ways and have produced similar creatures and similar life forms.
In the chat room, they ask a question, Professor. They say, is there, it's from Zeralath Immortal in the chat room. He said, is there the potential for spontaneous generation for humanoids, or is it just simple organisms?
I think about Himalayas, I do not know. I think spontaneous generation is particularly related in terms of the current thinking to microorganisms. I think it's wrong. I think there's no evidence at all for any spontaneous generation. The probabilities are enormous. The probability hurdle for starting from the components of life to making even the simplest living form or even non-living form, a virus or a bacterium, is super astronomical. I mean, I always remember the description that Fred had in one of his books that spontaneous generation of life is like saying that a tornado blowing through a junkyard could put together a fully working Boeing aircraft, Boeing 747 in those days. So these are huge probability hurdles, I think, that one has to overcome if one is to maintain the standard point of view in relation to spontaneous generation, in relation to life in the universe. I think it is flawed right from the beginning, and I think the new evidence that we're getting right across the board from astronomy, cosmology, to even microbiology goes against that thesis. So the counter argument, counter thesis is that life is a truly cosmic phenomenon. All the components of life, all the attributes of life are derived mainly at a cosmic level, not at a small planetary level. I mean, it's getting bigger beaks, or the Darwinian evolution takes place, but there's just fine tuning. That's just playing around with the details. It doesn't achieve very much, but the big changes also always have been dictated by the universe at large. That's been our point of view.
Yeah. I mean, you think that we'll ever get back to the past where to be an adept, you had to be an astronomer and a priest. You had to be a warrior
and a yeah and a scientist in one, right? And I think that's where we're missing out when we for the universal truths. I mean, you can't just be into it's like we keep spirituality and mysticism completely different than science when they should be merged together.
But I don't know. I think across all of the human aspirations, and I would include sort of poetry and art and music and science, the boundaries are really artificial. All of these human activities are connected with exploring the universe, exploring the cosmos, right? Music, the cosmos of sound, and the artist, the universe of colors, right? And there's this, so it's the same process that is involved in the workings of the mind of an astronomer, a poet, an artist, or a musician. I think the distinction is very minuscule. That's my point of view. I mean, the results could be different.
Yeah. Well, I mean, it's you have the music of the universe. It's connected to who we are, I think. I mean, what do you think about even the possibility of birds broadcasting the electron-driven chorus that's comes out of the plasma waves in the magnetosphere around Earth? It seems to be right before dawn. They seem to mimic those same sounds.
Yeah.
And
I
maybe
would,
it's
yeah.
stimulating plant life to open up their cells and receive the light.
I wouldn't rule out anything at this point. Our knowledge is so limited, and our desire to explore the relevant facts has been so absurdly limited. We've just turned away from connections that are staring us in the face, right?
Yeah.
Explore. So I think I don't rule anything out, and I think the main thing is to have an open mind, assess all the facts in all the areas that we're exploring in astronomy and biology and so on,
Yeah.
and arrive at the truth in this way. I think the truth eventually emerges, whatever you do.
Yeah, they have a place in Scotland, Professor, called Callanish, the stone circle.
Yeah.
And one of the mythologies they have, and this is a place where there's auroras there at a
Hmm.
certain time of the year. So there's a breakthrough in the magnetosphere. And one of the mythologies they have with the place, they say on midsummer, the Shining One walks up the avenue of stone heralded by the cuckoo's call. Now, the
Hmm.
Shining One is probably the rays of light walking up
Yeah.
the
Yeah.
avenues of stone, heralded by the sound it makes as it comes through the magnetosphere.
Yeah.
The cuckoo's call is the electron-driven chorus, I think.
Yeah. I mean, these are very interesting connections, and
Yeah.
similar stories. Uh, Connected with Stonehenge, right in southern England. There's this, I don't know how far it dates back, but I mean, Fred and various other archaeologists also have commented on the really mystical nature of Stonehenge, which seem also to be connected with astronomy.
Yeah, just like the Maruts of Vedic, they're like these golden solar dancers dancing in the winds of the cosmos.
Yeah, yeah.
You know,
Yeah, and the inherent knowledge that some peoples in the world, and you refer to the Vedic traditions, they didn't have telescopes. All of their knowledge was gleaned from deep concentration, meditation maybe, and delving deep into their own consciousness. And so the ultimate truths of the universe are there within each and every one of us. It would seem on that basis, because otherwise it's amazing that Indians have been the pioneers. Indian science has
oh, for sure.
been the inventors of zero, of negative numbers, of real, of sort of natural numbers.
In my opinion, Professor, all the ancient color cultures that we know of
Hmm.
emerged from Aryan Sanskrit,
Yeah,
you know,
absolutely.
Persian,
Yeah,
Egyptian, Assyrian, the Mitanni, all of those cultures.
yeah. Yeah, they all converge on this one little spot on the earth. Not so little, but the Indian subcontinent. It's been
Yeah.
the
It's incredible, the Asura and the Devas. I mean, even people don't realize the name Osiris is really Asar, which comes right from the Asura,
Mm,
you
mm.
know, name. All of those ancient cultures, it's incredible. They had such advanced knowledge, I believe, in the Rig Veda and the ancient Vedas that we can't even fathom.
And they didn't have telescopes. All the knowledge
Yeah.
that was indeed knowledge was prized out from their minds. It was within the human mind uh, is the whole story of universe, the whole story of life is there for us to prize out and to understand.
So this picture that we have in front of us that you sent with me with the E. coli, can you explain what we're looking at here for
Uh,
everybody?
yeah, this I think was a turning point because in the late 1970s, early 1980s, we were making very, very strong statements that life is a truly cosmic phenomenon, and therefore the components of life must be everywhere. And what we did then was to influence an astronomer who was my brother, in fact, Ra Wickramasinghe, who was an astronomer in Canberra, to look at the most distant objects, infrared stars. These are actually infrared emitters in the galaxy, near the center of the galaxy, and to look for the signatures of a bacterium, because that light from the center of the galaxy has to travel thousands of light years before the light reached us. So it goes through many, many clouds of cosmic dust. If these cosmic dust clouds were made of bacteria, then surely the spectroscopic signature of a bacterium must be imprinted in the starlight that we receive on the Earth at our telescope. So this was a prediction that we made, and then we got a student in Cardiff to make measurements in the laboratory of a bacterium desiccated, all the water taken out, and the the curve was the curve that was for a bacterium, the fingerprint, if you like to call it, of a bacterium. The points are the astronomical observations of the distant object that was essentially had this imprint of a bacterium on it, and the fit was so close that we thought this was it. And from this point onwards, we really didn't have any hesitation to say that we have proved life is a cosmic phenomenon. Fred, me, my brother, and a group of our colleagues. But there were many people who said that, oh, what you've really shown is that a bunch of organic molecules in the right proportions, that's important, in the right proportions, mixed together and thrown in space would produce the same spectrum. In other words, take a bacterium, break it apart into all its components, throw it around in space, and then you get the same spectrum. True, but how do you get the components precisely in the proportions that exist in the bacterium? It's totally rubbish that was used to counter or to challenge this point of view. So this was a curve and a fit that was commented on by lots of astronomers, Carl Sagan included, who said that maybe this is interesting, but maybe a bunch of organic molecules, simpler than life, could do the same thing if you mix the stuff appropriately. If you do the right hokey pokey jump and do the magic necessary for mixing, you will get the same result. But this fit was never essentially disproved at any time from the late 1970s right through to the present time. We found the same fit, the same comparison for comets that were explored in the solar system, and same in the external galaxies and so on. And when so this is a whole suite of molecules that are essentially present in the bacterium. Now in 2024, when they find a really simple biological molecule in a distant planet, they make a big fuss about it and they say they prove life, right? The proof of life is already here in this curve, right? And we should have been duly acclaimed at that time. Instead, it was such a profound conclusion that we reached that people got frightened, people stayed away from us. We were essentially the baddies in a group of people who really, at that time, thought that life is only present on the earth, that life is a purely terrestrial phenomenon.
Look at Giordano Bruno. I mean, he got murdered just for saying that there were numerous suns and other life out there.
Right, yeah, yeah. I mean, we've endured uh, insults and so on, but fortunately, civilization had progressed to a point where assassination, murders of that kind were not permitted.
Yeah, now they just assassinate your career and your
They try to,
your
they try
respect.
to, yeah, they try to do that, but I think it's getting more and more difficult, and I think
Yeah.
in the fullness of time, the right ideas always come to the fore, isn't it? Given the right conditions, given the right
You know,
sociology.
they have a term in America called haters,
Yeah.
right? And you would think that some of the most smart people in the world are astrophysicists, astronomers, mathematicians. You wouldn't think that they would be haters.
No, they wouldn't. You wouldn't think they were haters, but they're haters of any ideas that challenge theirs.
Yeah, they don't like if someone else has a nice idea that pans out.
No, they don't. No,
No, because they didn't have that idea.
they didn't have that idea.
Yeah.
If
Horrible.
if an inferior scientist has the idea, they can easily squash it and say that this guy has no valid credentials. But they couldn't do that for Fred Hoyle or for myself easily.
That's true. That's true. That's true. You know, I've always had a lot of respect for Sir Fred Hoyle. I would have loved to be able to converse with him, and
Hmm.
just having correspondence with you is something I really cherish, and be able to talk to you like this and ask you these questions, and people really respect you coming on in the chat room and having these conversations. It's taken a lot of courage over the years for you to be able to stick to your guns. And I could imagine that it's taken a lot of courage for you to even carry through with a lot of this over the years.
Yeah, yeah, I had to endure a lot of insults, punishments, and so on. And I always thought, and Fred Holtz was always there, or for a long time was there to back me up. I thought the truth is the most important commodity, and
Should be. Yeah.
to
Should be the
sacrifice
absolute
it,
truth. Yep.
to sacrifice it for any minor gains was not the right thing to do.
Yeah, for sure. Before we go, one or two more questions. And you also have a new book out, right?
Well, we had a set of articles that were essentially bringing up to date all the recent results, and hasn't come out yet. It's about to come out.
Unraveling Our Cosmic Origins one, right?
Is that the title of it? It's yeah, something like that. Yeah. Have you got a copy of it already? No, I don't think so.
No, but I was looking it up that it was coming out, so I was looking up to try to get it.
Yeah, I think it's out almost now, and some colleagues have ordered hundreds of copies of it. So,
Awesome. That's what everybody I have many books. You guys can have one he's did with Robert Bouval,
oh
Cosmic
yeah, yeah,
Womb,
yeah, yeah, yeah,
all these ones with Fred Hoyle, like
yeah. You got all those. Yeah,
Cosmic Life Force. Look, there's Cosmic Dragons.
yeah. My God, you're a good supporter of all these. So,
Yep, Evolutions from Space,
uh,
Diseases from Space. I don't know if you're in this one. This was that Fred Hoyle one, Intelligent
yeah, and
Universe.
I know that well. I know that
Yeah,
well.
love that one.
Yeah, I think I mean with the collection of books that we have here, I think joint books we had 35 altogether, and you've got
Wow.
and
Wow. I have a few others in the other bookshelf too. I was just picking some up before.
uh, and in terms of scientific papers, we've got a total of some 300, nearly 400 scientific papers in peer-reviewed journals, but the peer review suddenly started blocking us about 5 or 10 years ago. But
Wow.
most of the powerful results are in journals that people should respect, like Nature. We had 60 odd papers in Nature, right? And
Yeah, I
then
have some of them.
anyway, I mean, I think the sociology of science shows up very clearly in our interaction with the scientific community.
And you
uh,
never started out wanting to really get into biology. It just sort of happened with your interest into space, right?
absolutely. Yeah, I was interested in. I was more to begin with, like in my career as a young man, I was more interested in the arts, in poetry and so on, than in science. But then it turned out that I became interested in mathematics and applications of mathematics, and it certainly turned out to be astronomy.
It's amazing. Before we go, one more question. What's your opinion on what they found on Proxima B, the lights?
Well, I think I'm still have an open mind, and I don't know what they found. That is.
Think they found something like they might think it could be city lights or something on Proxima
No,
B?
I don't think they're city lights. I think there's some fluorescence phenomena or something. I'd still like to know more about
You think it could be like some sort of auroras,
something like that. Yeah,
something like that?
I would prefer that to, in the absence of,
That's what I figured. It could have been some sort of stellar wind that we don't understand or
yeah,
something.
some something like that. I think to go to extreme hypotheses with minimal evidence is always wrong, even though yeah, it might sound attractive to do so. I think
Yeah. I
we've
think
got to
a lot of astronomers want to be rock stars. They want to say aliens and you,
yeah.
yeah.
Yeah, I think the aliens are there, and there's no question about it, and they're denying it in a big way, and they wouldn't be able to deny it for too long.
Oh, for sure. I would love to see the dolphins that you talked about on Europa.
Well, that's a I don't know whether that's really going to be
That would
true.
be cool if Arthur C. Clarke got that right.
Uh,
Well, Professor Chandra, it is a pleasure to always have you on. As soon as you want to come on to promote your next work that you're doing, it would be a pleasure to have you on again. I love catching up with you, everybody. The living legend, astronomer, astrobiologist, mathematician, Professor Chandra Wickramasinghe. Thank you for coming on the Space Water Podcast. It's always a pleasure to hear it from you.
Thank you.